So good morning. As Pach said, I've been working on the web platform for a really long time. In fact, this is me at my very first web conference ever. This is the Web Wizards conference in 1993. And I bring this up not because of the awesome hairdo, but because I've been at this a really long time, and I have to say, this is one of the most exciting times in the development of the web. We're finally at a place where the web platform can be used to build really awesome, seamlessly engaging applications, which is something I've wanted for years, decades. And this is really no less revolutionary than what happened in around 2005, when the pattern of Ajax transformed the web from static pages into dynamic interactive experiences. When the expectation of user experience went from clicking on the side of a map in MapQuest, waiting 30 seconds or so to get a new tile downloaded, to Google Maps, live panning, zooming, that kind of stuff. You didn't have to spend 30 minutes installing native software. You didn't have to live with this horrible click and wait experience. But this has really been a lot more successful in the desktop web than the mobile web. So raise your hand if you've used Maps, doesn't have to be Google Maps, on your desktop, like on the web. Pretty much everybody, right? Now, how many of you have gone to the web to get a map from map software on the web on your mobile device, rather than the native application? Yeah, not very many. There's always a few, by the way. You're a special group. But most folks use a map application on their phone, right? And this is important because mobile is what's at the bottom of this revolution. The explosion of computing usage in mobile right after the explosion of the web is changing the computing landscape yet again. A year or two ago, depending on whose stats you use, mobile computing use outstripped desktop computing use. We're using mobile devices more for computing than we are traditional desktops and laptops. And on mobile, users tend to spend most of their time in native applications rather than the web. This is changing a bit, but as of last year, only 13% of users' time on their mobile devices was on the mobile web versus 87% spent in apps. And apps are more predictable. Like, they have some great re-engagement features. They give you notifications, home screen icons, all kinds of neat stuff. And it kind of seems like I could just stop here, say, go build native apps, and we could be done. But there's a flip side to this. First of all, app usage is highly, highly concentrated. So users tend to only use a few applications. It's kind of a winner-take-all situation because based on user studies, people see native apps as kind of a big commitment in time and space and cost, like maintaining the application on their device. Native apps are engaging, but only a few of them are worth installing. And I'm sure you probably heard, according to a recent study, the average user is installing 0 new applications per month. 0. They're not getting anything new. They're just sticking with the apps that they have. By contrast, mobile users, according to our own data, they visit over 100 websites per month. So more than 100 apps, 100 websites per month that you're visiting. And this is really, to me, the power of URLs and the ephemerality of the web, is you can meet these one-off needs. You can get additional stuff much more easily. One way to think of the difference between native and web has always been the capability access. Like, native apps have the ability to start up reliably when you hit their icon. They boot up quickly. They tend to work offline. They can send notifications. They can hook into Bluetooth devices and microphones and cameras and stuff like that. But if we could add that set of capabilities to the web, fulfill those set of expectations, we can have the best of both of those worlds. And this is really what progressive web apps as a term is supposed to represent. A user experience that's good enough, that's integrated enough to earn a place on the user's home screen and in their notification tray, but without losing that reach and that ephemerality to get there. And if you don't remember anything else that I say today, this is the one thing that I want you to walk away with. Progressive web apps are really just a whole new level of caring about your end-to-end user experience. They're not about a set of technology. They're not about, a specific piece that you have to implement. And there are those pieces too. But the core is just caring about end-to-end, how does a user experience your application? This, by the way, is an echo of something that Ben Galbraith said a decade ago. In 2006, I think I finally figured out which conference he had said it at. And he said about Ajax, Ajax isn't about technology, it's about caring about your user experience. And that resonated with me so well, I remembered it a decade later, and I'm not just sucking up because I report to him now. But in order to get those user experiences, in order to build that new level, we need to improve applications that are built on the web on three main fronts. First of all, web apps really need to be much more reliable because we've become used to always being online, right? So when we see this cute little creature, the dinosaur, by the way, I'm making dinosaur a thing, go tell everybody else, it's the dinosaur. It's a disaster, right? Like it destroys your web app experience because offline just doesn't really work on the web. Who here has opened up a web browser to use a web application when they absolutely know they do not have a network connection? That is way more than usual, and it's still like 5% of the audience, maybe. Like that's horrible. That's not a good offline platform if only 5% of the people actually expect it to do anything. And the worst part is that mobile devices don't even necessarily have a network connection or not have a network connection. They exist in this kind of Schrodinger's cat state of cell network connectivity. Even when it looks like you have a connection, you may not. Sometimes when it looks like you don't have a connection, you do. And it's not just no connection that causes a problem. Slow connections, intermittent connections, all kinds of states affect users at least as bad as just flat out not having a connection. But mobile apps don't ever show us the dinosaur, right? Nothing on my home screen except for Chrome ever shows me the equivalent, the direct equivalent of a dinosaur. Sometimes they say, hey, there's no network, I can't do anything more than this, or I can't do whatever you tried to do, but they don't just flat out not work. And in order for web apps to earn a place on users' home screens, we need to make them reliable, even though the network isn't. Now, secondly, user experiences need to be fast. And I'm not going to say a whole lot about this, but users don't expect janky scrolling. They don't expect slow loading. The web has had a bad name for performance. I think we've addressed a lot of that, particularly on mobile, in the browsers. But this is a continuing journey. We need to keep making faster and better applications. And this also underscores reliability. Because you may have heard the saying, time is money. Well, this is definitely true for web users. Studies have shown up to 40% of users abandon a site after 3 seconds of it not loading. 3 seconds. Like, I'd make a joke about kids today, but this is totally me, right? If something doesn't load, I bail out, go find a different site. So loading a web app has to be invisible. It has to feel instantaneous as part of that process. And then finally, of course, great user experiences have to engage users. And when I say engaging, it's kind of a weird term. Think of this as offering an integrated experience. The app should feel like it belongs on the device, not belongs inside a tab, inside a browser application on the device, but actually on the device. It should just feel like part of the computing experience. So they need to feel immersive. They need to have a proper place on the home screen. They need to re-engage users, right? They need to be able to notify users. On mobile devices, notifications are now just a fundamental part of turning a monthly active user into a daily active user. Like, they really unlock re-engagement and a bunch of other use cases. So I want to walk through what a good experience built as a progressive web app can look like and what it means. So this is a progressive web app that the Washington Post has built. You can go load this right now on your mobile device, wapo.com/PWA. And at first, it just loads like any other site, right? It loads in a tab in the browser. And it's a well-designed mobile experience. It's smooth scrolling, responsive design, all the rest. But silently, it's doing a little bit of magic. It's installing a service worker, and it has a manifest. So after you use it for a while, or if you revisit it multiple times, you get this. You get an add to home screen prompt. It says, this isn't a banner that the Washington Post offers. This is actually Chrome saying, hey, user, you're using this site a lot. Maybe you want to add it to your home screen. So if you tap the accept button, then the browser lets you know it's added it to your home screen. And if you go back to your home screen, you get an icon. You tap on the icon. And now, when it loads, you get a more immersive experience. We don't start with a flash of white and a blank browser window with an URL bar. We actually give you the app's splash screen. And I'm not pumping up splash screens because I don't think they're awesome. But it means you're at least in control of that experience. You can give it a black screen if you want. You can have it white. You can have it your theme color, whatever. And then it runs full screen without an URL bar. And this is where I'm really happy Jeremy's already left because he can't heckle me from the crowd about URLs. But the idea is not to hide URLs. It's that the web developer should be in control of what the user's experience is. Now, the cool thing, too, is that this is kind of not really the browser anymore at all. Because if you tap to get to the task switcher on Android, this app is top level, right? It shows up just like any other application. It doesn't show up as a tab inside Chrome. It just shows up as an app, like any other app. Now, by the way, in this application, the Washington Post managed to get their load time from a cold start, second load, obviously, down to under 80 milliseconds to first page. Like, this is amazing. Their newsroom, their executives, they were super excited by this. They're actively evolving this to become their core mobile experience across the board. It's still a demo at this point. But this experience is reliable. It actually does work when offline. Like, I've loaded this on my phone when it's offline. And yes, the news headlines are old, but they work. They show me stuff, and it loads up instantly. So when you think about what you need to do, what you can do to do this sort of experience, to improve experiences in your own projects, I want you to walk away understanding the new set of APIs, understanding service worker, that kind of thing. But I want to underscore the key point here, which is this isn't about this technology necessarily. Just like with Ajax, the first step is examining your end-to-end user experience. And examine your performance, your simplicity, your responsiveness, both to user input and to device environments. And as Jeremy said yesterday, identify the core functionality and make it available using the simplest technology. Like, this is going to get you so far along the path to building a great progressive web app. So to start, by the way, you need security. You need HTTPS. You need to securely serve everything you produce. Make sure you have the green lock icon. This is kind of table stakes for the web now. Like, this is the new normal, is HTTPS. More and more powerful APIs are requiring HTTPS, requiring secure domains. A lot of old APIs that were powerful that we really should have required it for before now do require it, like geolocation, for example, or get user media requires a secure domain. Now, in the past, this has seemed kind of daunting to a lot of developers, primarily for two reasons. Getting a certificate and serving it could be expensive, and a lot of developers feared that they would lose their search ranking as their URLs changed from HTTP to HTTPS. So on certificates, SSLmate has been offering certificates for years now for like $16. This shouldn't break the bank, even if you have multiple certs. Let's Encrypt offers free certificates, so really you don't have a huge excuse there. Yeah, both of these offer automated command line tools, by the way. You can make sure your certs aren't going to expire on you, that kind of stuff. And as for search ranking, between using 301 redirects and canonical links in your docs, you really shouldn't have a problem with this. We have a bunch of guidance, though, to make sure that this isn't going to affect your search ranking. We've published all these best practices. There are a couple other things you should probably do, too, so I'm not going to go into all of them here. So once you've built a secure domain, once you're offering everything securely, you're ready to build a service worker. Now, who here understands what service workers are, have a pretty good idea how to build with them, how to use them? OK, cool. This is my fork point. I actually have a little note in myself, fork point. Tells me that I am going to have to keep talking just as fast in order to finish in half an hour, because I can't skip anything. So the traditional web model has been this. When you type in a URL, you select a bookmark, whatever, the browser goes to the network to fetch the page. And I'm going to skate past the HTTP cache because it's really part of the network in this case. If the network's down, you get the dinosaur. We can't load anything. But you don't necessarily need to traverse the network every time to ask for a resource. Instead, if you have a service worker, the service worker is a JavaScript file that the web developer writes, and it's basically a proxy server that sits between your code running on the client and the network. So when a page registers a service worker, it also adds a set of event handlers to do things like event handle when you try to fetch something. And the service worker can also manage caches of data, caches of files or resources, and you can decide when you get a request, when you handle a fetch event, what to do with that. Like you can serve it from the cache, you can serve it from the network, you can do whatever. And because it's event-based, the service worker isn't running all the time. It doesn't need to be in memory unless it's actively handling one of those events. In fact, I want to underscore that again and say it again because the service worker doesn't consume any system processing unless it's being woken up to handle an event. So even if the browser is closed, by the way, the operating system can wake up a service worker to handle an event. And we'll get into that when we talk about notifications a little. But we're no longer limited to this model where in order for the app to be at all useful, it has to be loaded in a tab actively right now. And this is important because you now have an app-like lifecycle for the web. You can install resources, you can handle requests, even if the user doesn't necessarily have you loaded right at that time. So when a service worker is first registered, it fires an install event. This install event is important because this is where you get to do stuff up front. You can prefetch resources, you can cache them locally. You basically have a fully scriptable install. You can do whatever you want within some boundaries, of course, within this install process, much like a native app can. Once the service worker has been activated, and it's actually servicing requests, you're the one in control of how to respond to fetch events. You can inspect network requests before responding to them. You can rewrite them. You can pass them directly off to the cache. You can pass them off to the network. You can even synthesize your own responses. You can replace every resource request with cat pictures if you want. Totally up to you. But all of this is completely transparent to the user, and more importantly, to the client web application. Like this is a separate bit of code that sits between the client web app and the network. And you can really build a well-constructed service worker as just a super smart caching system that understands how your app works. It's a progressive enhancement of the network and choosing smarter ways to respond to requests. Now, when I say that this is a progressive enhancement, I want to be clear, the first time you load the page, the service worker isn't there. Like the service worker gets loaded by your page, so the first time you load up your site, your app, whatever, it's still going to be loading from the network. You load index.html, and it loads up, and it sees all the resources in it, and it fires off the requests for those resources normally over the network, just like it always would. And at the same time, it's installing the service worker. So the service worker comes into play on subsequent requests, subsequent loads of the page, not the first load. So let's take a look at what this actually looks like so you get a feel for how difficult or not difficult this is. The first step, like I said, is registering a service worker. And of course, the first step to that is put in a bit of logic to make sure you actually support service workers before you do this. And then if you do support service workers in the browser, then you simply register by calling navigator.serviceworker.register with a reference to the location of your service worker JavaScript file. Now, the location is actually important. It has to be in the root of whatever domain you want it to cover. So if you can't put it in /js/ unless you only want it to come into play for stuff inside your JS directory. Like this is why it's /serviceworker.js a lot of the time. Next, we need to handle the install event. Like I said, this is fired when the service worker JavaScript file is parsed and loaded. This is where you get to prefetch resources, cache them locally, do whatever kind of scriptable setup you want to do. So the easiest way to do this, or one common thing to do is open up a cache object. Cache is also a new API. It's designed specifically for storing URL-accessible resources. You give it a name, whatever name you want. This is how you can reference, or how you can keep multiple caches and version them. And then use cache.addAll to add any resources that you want and get them store them in the browser cache. Go download them over the network. And by the way, if this were a real implementation, we would want to catch any exceptions here. Like, if these files don't get loaded, bad stuff happens in this code example. So don't just go put this into production today. But at this point, so like now we have a cache. We have all of our local files, all the files we need for our web application are now loaded. But if you were to go offline, you're still going to get the dinosaur. Because we've done a lot to pre-cache everything, but we didn't handle the network event. We didn't handle the fetch event to say, hey, get that stuff out of the cache. It's still going to hit the network. The default handler for fetch is still go to the network, just like always. So instead, inside your service worker, again, you add an event listener for the fetch event. And when a network request is made from the web page, from anywhere in that domain, the service worker wakes up, and this fetch event gets triggered. So in this case, the easiest thing to do, since we have a cache that some stuff is in, we check to see if it's in the cache. If it is in the cache, return that. If it's not in the cache, pass it on to the regular fetch, like pass it off to the network effectively. So now we have a reliable experience, loads almost instantly. Our app's going to work whether we're online or offline, or at least it's going to get all its resource requests, whether we're online or offline. And it's really fast because it's coming straight out of the cache. Our last step is, once we're activated, we actually send a message back to the page to say, hey, the service worker is ready to go. There's a deeper topic around how you can swap these service workers in and out and how they version. I don't want to get into that right now, though. But this is helpful because you can actually indicate now in the main page, in your user experience, you can say, hey, I'm offline ready. Like, I've stored stuff. You're ready to go. Like, you have communication between these two, between the service worker and its cache and the local client. And the important thing here is to understand that you're in control of how you respond to network requests. You get to decide what gets cached, how it gets cached, if it gets cached, and how it's returned to the user. You can change anything in this. You get to hand design the caching strategies for each and every resource, depending on what you want it to do. You can have the cache and the network race to see which one's fastest. Turns out sometimes the network is actually faster than the cache, depending on what device your cache is on and how slow it is. On that topic, my colleague Jake Archibald wrote a great offline cookbook a year or two ago that covers a lot of these things. It gives you some ideas of how to implement each one of them, has sample code. This is a great resource to go back to and look at for ideas on how to do this. So once you have a service worker, and once you've figured out how to make your app reliable so it can still work offline, it's cached its core resources, all that kind of stuff, now you can unlock a bunch of user engagement features. And when I say user engagement, again, it means a whole bunch of things. And the very first one of these is the home screen. This is the center of a mobile user's world, right? Like, everybody looks at their home screen all the time to run applications. And we've been able to add websites to the home screen on Android and iOS for quite a while, but the user experience has not been so incredibly great. The way to add this was pretty painful. Users had to know about the Add to Home Screen menu item inside the hamburger menu in Android Chrome. And, oh, by the way, on some devices, like my Nexus 5, it actually wrapped. It was below the fold. You had to scroll the menu up to find it. Unless you were on the home page of an application, when you hit this, it would always go to that place. There was a month or two in there right after I'd made a home screen icon for Facebook before I realized that I'd actually added to the home screen a particular conversation, particular post, and every time I would go to what I thought was Facebook, I would go to this post instead. And then, of course, finally, nobody really expected that these would work offline. Like, there wasn't this expectation that it was going to work just because it was on the home screen, which really kind of devalued the home screen, right? You suddenly had some apps, some icons on the home screen that would work, some that wouldn't. So yeah, from a user perspective, this was totally fine. This is great. But we wanted to do better than this. So now we have a web app manifest. And this is a JSON file that gives the web developer the ability to control how your app appears to users in the places they usually expect to see apps, like the home screen. You can direct how your app is going to launch, what it's going to look like in various representations. Like, you can control the presence on the Android home screen, what short name it gets, which icons are used at various resolutions. You can refine the splash screen to be whatever you want it to be. You can also define where the core of your application. When you tap on this icon, always go to this URL, not something that the user had loaded at some point in time. You can launch in full screen. You can control the default orientation. I have a web audio, web MIDI synthesizer app, and it always wants to be in landscape because it needs to stick an on-screen keyboard on. So I can enforce that. And then also, partly due to our switching within Task Switcher in Android, you can define theme colors because that's the app bar color that represents your app. You can control these things that are like the interaction between the OS and the app that the user is used to. So manifests are supported by Chrome on Android, Firefox, Opera. Microsoft has indicated support for them. Unfortunately, Safari on iOS, you still need to use traditional meta tags, but you can get a lot of the same controls that way. And then this was great, but we still needed to deal with the fact that this was buried in a menu item. So we decided, hey, what if we automatically prompted the user to install? If we know these apps are really reliable, and we know the user's already interacting with them, we could just load them automatically. We could prompt the user and say, hey, do you want to put this onto your home screen? We don't want this to be spammy, and this is the biggest concern. So we want to make sure that the user is really engaged with the app. We also require offline support because we don't want to devalue what home screen icons mean. And we require that there's a manifest. That way we can get a consistent user experience. But if you have these things, then we have a heuristic that says, hey, the user, after using this app for a while, will automatically get this prompt to say, add it to your home screen. And this means we have these requirements are the promise of progressive web apps, that you're going to have a great, reliable, offline capable experience. And when I say offline capable, obviously, doesn't mean everything's going to work, because sometimes you do need the network. That's what it's there for. But at least you know the app itself will be able to load. And then once we have this, we can actually offer push notifications too. We can re-engage the user once they've been engaged. And this, of course, is another permission. Like, the user has to say, yes, it's OK to send me notifications. But this is now available to web applications as well as native apps. And this is a critically important thing, because if you have an engaged user, you can re-engage them regularly, even when the browser isn't open. And this is the biggest, coolest thing about push notifications, is that they run even when the browser isn't open. Now, this isn't just a Chrome thing again. Microsoft is working on them. Firefox, Opera, Samsung browser supports them. No clear indication from Apple yet, but fingers crossed. And this really does help re-engage users. Jumia, who's a leading e-commerce website in Africa, they used to have nearly a quarter of all shopping carts abandoned every day on their mobile site. They were trying to send email reminders, but getting people to give you their email address, of course, is kind of a challenge. And email open rates are pretty low. I don't know about you, I get tons of email from retailers that I just delete without ever opening, even retailers that I actually do buy stuff from regularly. So they began sending push notifications to users who had abandoned their carts. And this delivered a 38% open rate, which may not sound like it's very high, but this is 9 times more than they were getting before. Like, conversion rates from push notifications were outstripping their native app's ability to re-engage users too. And to add push notifications, again, this is also built on Service Worker. because service workers can do more than just handle network requests. They can reply to other requests, like a push message sent from outside the browser into your service worker. So push is awesome. I'm not going to go into it anymore, other than to say, if your app scenarios seem like they align with it, it's a really, really cool technology to investigate. So to recap, build on HTTPS. If you're not building on HTTPS already, if your service isn't offered securely, go do it, because this is the new normal. Add a service worker, engage your users by adding a web app manifest, signal that you actually are building a great app. And this is also what happened with AliExpress, which is, AliExpress is like one of the largest e-commerce players globally. They're based out of China, but in that market they have a huge, huge market share. And they shipped a progressive web app, and within days they saw a 74% increase in time spent on the app, and twice as many pages visited as they had before. And the number that really matters to them, of course, is not how much people are visiting their site, but whether users actually converted, whether they spent money on their site. And conversions went up across the board, but the most surprising thing was that since most of these progressive web app features don't work on iOS Safari, you wouldn't think that it would help much, but they actually saw an 82% increase on conversions on iOS alone. Even though the service worker didn't work and the engagement stuff wasn't really working, this seemed a little crazy, but again, progressive web apps are about being progressive. It's about focusing on that experience first. And that actually is what they did. They built a great application and then just happened to have the service worker and engagement pieces to make it even better. So even though some of our early examples weren't progressive across browsers, devices, et cetera, progressive web apps really need to be. They can be, they should be, and that is a core component. Like focusing on this end-to-end user experience will have a dramatic impact on your business, even with users who can't experience the full power of progressive web apps. So focus on the user, not the technology, even though the technology is pretty cool. And with that, I want to offer you to go build progressive web apps. We're going to have a discussion panel later this afternoon, I believe. Happy to answer questions there. Thank you.